Okay, guys, we'll start the review today. This is ACS live exams from the study guide, and if you look, it will come something like this. Now, I'll give you 1 minute and try to solve this one here, and we'll solve it together. So 1 minute, so try it yourself. We are looking at the mole ratio or coefficient ratio, and you can see at the underline, those are coefficients. So give you 1 minute to solve, and then we'll start doing them together. Okay, guys? So everybody can do it? The first one. So what should I do first, you think? What should I do first here? What type of reaction is this to begin with? What type of reaction is this? You react the compound or chemicals with pure oxygen. This will be what? Combustion reaction. First, the type is combustion reaction. That's the type of reaction. Now, balancing chemical equations in general that does not have any really strict rules. The best thing is just keep trying, trial and error until you get all the number of atoms at the left side of the chemical equation equal the number of atoms at the right side of the chemical equation. So, for example, here carbon is 7, correct? Here carbon is 1, correct? So how about putting first, get carbon out of our way, put 7 here. So I have carbon, done deal. And my intuition will tell me keep this one here, a molecule by itself, or there's nitrogen, oxygen, anytime by itself, keep it at the end. We'll balance oxygen at all the way at the end. Hydrogen is 14, however it's here 2. What should I do here? 7, correct? So now we'll have to have the oxygen. So here is 1 understood, not written, we did not add anything. Now the oxygen. 7 and 2, how many here we have the oxygen? 14, correct? Plus 7 and 1, how much? Plus 7, correct? So how many is those? 21. Everybody agrees? Here we have 2. And here we have 2. 4, correct? Now since this is 1, I will keep this one as is. I'm not changing this number, but I can change this number here, the ratio, the coefficient, correct? So if I have 2 here, how much will be left? 19, correct? Everybody agrees? 19 and 2 will be 21. And since this is 2 here, I put 19 over 2. Why over 2? Because the 2 then will cancel with the 2. So 19 oxygen and 2 makes 21. Make sense? Make sense? I put 19 over 2. So then I will say, okay, nature does not support any fractional atoms or molecules or ions, so I have to get rid of these 2 here. I multiply the whole equation by 2. So I have 2, 7, 4, H14, O2, plus 2 multiplied by 2 makes 19, correct? O2, 2 multiplied by 7, 14, CO2. 2 multiplied by 7 is 14, H2O. Now, let's confirm this is really true. We'll see. If it's not true, then we have to reshuffle it again. How many carbon I have here? How many carbon? Carbon is 14 here, correct? Carbon, how many is here? 14. So carbon is correct. how many hydrogens I have. 2 multiplied by 14, hydrogen is 28, correct? And hydrogen here is 14 multiplied by 2, hydrogen is 28. So hydrogen is good, hydrogen is good. Now the problem is with what? With oxygen. 2 multiplied by 2, this is 4. 19 multiplied by 2, 4 plus, this is 83, correct? Am I correct? 38. This one here will be 42, is it? Am I correct? So, 14 multiplied by 2, how much is this one here? 28. 14 multiplied by 1 plus 14. Is this 42? Yes? So, what's the more ratio then? 2 to 19 to 14 to 14, correct? So, which is the correct answer? Was that? B. This is the correct answer. Everybody agrees? Everybody's following? Make sense? Okay, so can I take this one out? Everybody has it? Okay, let's take this one out and double check the answer. They do have the answers here. So the second page is the answer. Here's the solution. Tell you, and the answer is B. The answer is B. Here it is. I'll circle it so you can get the idea here. The answer is B. So we did good. We did good. So let's take this one out, and let's take the second one. Now, this is a very good one, but very simple one. So now you balance it while I'm taking my caffeine here a little bit. Okay, guys, can you tell me how the answer of this? So, what should I do here? Okay. Any opinion? Any feedback? Any inputs? So, what should I do? We did the most difficult one. The previous one was very difficult, correct? This one very simple, correct? So carbon is what? Is 1, correct? Carbon is 1, so I'm not doing anything for carbon. 1, 1. But of course 1 is understood, not written. But when you write the coefficient ratio or the mole ratio, you have to put the 1 there, okay? Hydrogen is 4. Hydrogen is 4. Here hydrogen is 2. So what should I do here in front? 2. So hydrogen now and carbon is good. So hydrogen is good, hydrogen is good, carbon is good, carbon is good. Only problem is with oxygen. How many oxygen we have here? 2, correct? And how many we have here? No, 1 understood, not written, but 2 in front of it. Plus 2, so here is 2. So this is 4, that's for the oxygen, correct? So what should I put in front of this? 2, perfect. So the ratio will be 1, the mole ratio or the coefficient ratio 1 to 2 to 1 to 2. Where is the option looks like it? Which one? A. Perfect. So, any question? Any question? So let's see what they have. But that's, even if they have different, I think we are convinced ours is correct. Always have the something inside your brain say, I am correct. Not always depend on this, test bank answers, and you have seen some test bank answers sometimes are not correct. Okay, so they are made by a human, not by artificial intelligence or something like this. Okay, so let's see the answer. Let's look at the answer here. The answer is see, that's not correct. That's not correct. Oh, that's correct. That's correct. We are wrong. We are wrong. We did not. We said this is 2, correct? Let me see. This is 2. This is 1. This is 1. This is 2 here. This is 2. Correct? This is 4. Well, you did 2 here. No, we are correct. Answer is A. Yeah. Our answer is correct. Their answer is not correct. Yeah, I just double check it. See?
So if that happens on the test, do we?
No, we'll verify it, and then if it's not, then everybody will be compensated for. But that's not correct. The answer is not correct here. So the answer is not correct. The answer is A. You have seen it yourself. 1, 2, 1, 2, and you can verify. So let's take third one. Here it is. How many moles of iron are necessary to react completely with 1.7 mole of oxygen gas? So, you tell me how much is it? So, always start whatever is given to you, and assuming the other one will be, if they want completely with 1.75 mole of oxygen, as oxygen completely is reacting, that's limiting. And the iron is in sort of an excess, correct, range. So how I solve those problems? Well, you start always whatever is given to you. That's the key. Given to you is this one here, correct? And asking for iron. That makes sense. Or the product, whatever is the product. So, how many moles of iron? So, iron moles will be, you start whatever is given to you, moles of oxygen. 1. Here is mole of oxygen, because you have to cancel. And you need mole of iron in the top. Mole of iron in the top. So the ratio is 4 what? To 3, correct? This is 3, this is 4. So 4 multiplied by 1.75 divided by 3. How much is it? How much? Now, can I make it for our product? Yes, I can. So how much is iron oxide, FeO3, iron 3 oxide. So how much is this? Mole. Well, you start whatever is given to you, mole of oxygen, then just the mole ratio will be different. You have 2 mole of iron 3 oxide to 3 mole of oxygen. So you can, even for the product, you can calculate. This is not, it's not apt, but I show you, you can calculate even for the product itself. So how much is it? Where is the answer?
2.33 C.
2.33 C. Okay, let's see if that's correct. Yes.
When do we use Barthel's number?
What's that?
When do we use Barthel's number?
Avogadro's? No, no. They ask you about the moles. The keyword when we have to use Avogadro's number, the keyword is atom, molecule, or formula units or ions. That's is a must. Whenever there is the word ion or formula units, molecules or atoms, that's a must. That's Avogadro's number. Before this, it's nothing. You cannot use them. You have to have those three keywords: atoms, ions, or formula units, or molecules. They don't ask about molecules. They don't ask about atoms. They don't ask about formula units or ions. Correct? Just pure moles. So pure moles, when they are asked, means you have to look at the equation, and then from the equation you can figure out the mole amount, as we calculate here. So the answer is C. Everybody said C? Okay, let's see. Can I take this one out? And you can even do for the products. You see here, I did for the products. I did for the product here. So it's not asked, but I showed you this. You can do it for the product as well. So let me take this one here, and then let's see. The answer is C, 2.33. Okay, that's good. So now this is the same thing here. How many moles of H2O necessary to react completely with 8 mole of phosphorus pentachloride? So you tell me how to do it. We did it before. You start whatever is given to you. This is what it is. This is given to me here. This is given to me. So I will start with this, whatever is given to me, mole of phosphorus pentachloride, correct? And it's asked how many moles of H2O. H2O moles. So in the bottom I have to cancel the units. Mole of BCl5 to mole of H2O, because they need H2O moles, correct? Has to be in the top. So what's the ratio then? The H2O is 4, correct? And the BCl5 is 1. So the answer is, where is it? The answer is 32. Make sense? No Avogadro's number here, because it's not, there is no mentioning of atoms or molecules or formula units or ions. Okay, guys, so that's what we did. So let's see. The answer is, where is it? D. The answer is, here it is, guys. The answer is D. So let's take this one out. Let's do the second one. Now you will see we are looking at the theoretical yield, which is based on the limiting reactant. We have two reactants are reacting at the left. We want to see which one is limiting. Okay? So what is the theoretical yield of aluminum chloride that could be obtained from 6 mole of barium chloride and excess of aluminum sulfate? So they give you the excess is aluminum sulfate. So this is, oops, sorry. Where is it? Yeah, sorry about this. So this is excess. This will be what? Limiting. So we'll base our calculation on our limiting reactant, correct? What is the theoretical yield of aluminum chloride that could obtain from 6 mole of barium chloride? Okay, so the limiting and excess of aluminum sulfate. So theoretical yield of, they give you what product they are desiring to produce or to consider. Theoretical yield of one, we have 2 products, correct? We have 2 reactants, but we are interested in just one of them. Your calculation cannot be based on 2, but you have to select one. And then you can select the other one. So one at a time. So they are looking for this. So what you will say, you start whatever is given to you. That's the limiting reactant. So you are looking aluminum chloride, number of moles will be, you have 6 moles of 6 moles of barium chloride. Now remember, barium chloride always at the bottom, mole of barium chloride, and we are interested in our product here. We have mole of aluminum chloride, and the ratio is, I have 2 here. I have barium chloride is 3. So 2 to 3. So that will be the answer here coming. 2 multiplied by 6, 12. 12 divided by 3 is, the answer is how much is this? How many moles? 4 moles. So 4 moles of aluminum trichloride. However, we need the grams. The answer in grams, not moles. So what should I do? Multiply this one here. I can make another, but I have no space. But I can multiply it by, it's what? Molar mass. Molar mass. Molar mass of AlCl3. So I take this one here, which is gram per mole, correct? So I say this one here is 133.3 gram per mole AlCl3. So mole of this, mole of barium chloride cancels out, mole aluminum chloride with mole. So this is 4 multiplied by the molar mass, which is multiplied by this amount here. So how much is it? C, because it has to be across 400 something, correct? So the answer is C. The answer is C. So 4 multiplied by 133.3. So you can tell that will be, that will be 534, because all the other ones are small amounts. So, and the 801 is too large. So the answer can be just C, close to the number we have here, correct? So, can I take it out? And then look how they can fool the students. They bring you other molar mass, but don't use them. You cannot use them. Why? You are interested in just one of the product, which is aluminum chloride. Specifically, they told you aluminum chloride. So all those here, the other molar mass, is just to fool the students. So don't be trapped into this. Can I take this one out? Take it out? Okay, so let me take it out. And okay, the answer is 533. Their answer is not even correct, 534. And the answer for the calculation is what? Yeah, so well, they made it sig fix. Well, they made it sig fix. I don't know. Maybe sig fix, I have no idea. But anyway, that can happen. So, next. This is another combustion reaction, and are you listening to me now in the back? What's the keyword? What? Then what we have to use? Perfect. You made my day. You made my day. You made my day. So, here's the key word. You really made my day. If I have molecules or ions, formula units, or atoms, then I have to use Avogadros. And you can tell those answers here have to be Avogadros there. That's large number, correct? Whenever they ask about molecules, then you are dealing with the large number. Everybody's following? So I give you maybe 1 minute to solve this, and then we'll solve it together. Now, don't expect those answers, their answers, 100% correct. We are doing it twice, 3 times. Our answer is correct because we are doing it collectively with all the groups here, and we are doing it more than 1 time to make sure that our answer is correct. So they have some problems with their answers. You have seen yourself. That's just homemade by one of the professors, I think. It's not from the ACS, exam. So which one is correct? Which one? Which one, guys? How many molecules are produced if you have of the propane? This is propane here. And they ask you how many molecules if you have 0.3 moles. You start every time with what? Whatever is given to you. It's given to you 0.34 mole of propane. Okay, guys? Propane, you can go to any gas station or U-Haul or anything. That's propane. It's called for cooking or barbecuing. That's a propane gas. So, what should I do next? Where should I put the Avogadro's number? Up or down? That's the key. That's the key. I have to cancel the mole here, correct? The mole propane here should be canceled out. Correct? Well, Avogadro said 1 mole, and I'm looking for the molecules as a unit. So, Avogadro's number of propane molecules. Okay, guys? Make sense? The mole cancels out. You just multiply this. Keep this one here by itself. Don't, whenever you calculate, because that sometimes brings an error, keep it at the end. Multiply this by this. Observe the sig fix. The sig fix will be controlled by the least number of sig fix. Avogadro's four significant figures. This is 2 significant. Your answer has to be what? 2 sig fix. That's correct. So now, how much is it? Do those so you can get training for your calculator, using your calculator. How much is it? 2.047. 10 power what? 23. See, I left the 23 as is. So which one is closer? I need two sig fix, correct? That's 2. So I take those out, so it will be 2.0. 10 power 23. Now they say 2.1. I have no idea. You calculate it. Are you getting the 0.1? No. You get a 0, correct? I don't know. So you calculate. So their answer is not correct then. It's not 2.1. But that's what the multiple choice is. Sometimes they put this on purpose to trick the students. So students is always will be, that's not correct. You just repeat yourself in your brain. The answer has to be 2.0 exact, according to the sig fix now, but you have 2.1 here. So I will take the one very, very close, 99% match, which is B, correct? So let's take this one out. Take this one out. The answer is well, you give me the answer is 8.2. The answer is C. Did we do this one correct?
If we multiplied it by the 4, then it
How many molecules? Oh, okay. That's. Hold on. We have 0.34, correct, mole of propane over 1. We say, correct, and then we have 1 mole of propane is Avogadro's number. Avogadro's number of propane molecules. Correct? 1 mole. So, how many water molecules are produced if 0.3 moles? Okay, so now, let's see here. They did it 0.34 mole of propane, correct? They're asking H2O or propane. What we calculated is the propane amount, correct? Not H2O. Oh, I'm sorry, that's my mistake. They are looking for H2O molecules. Okay? Our is correct if they ask for what? For the propane molecules. I calculated what? Propane molecules, just from my side. Over 1, correct? Then, the next step is to set up mole propane, correct? Their answer is correct. To mole H2O. Correct, guys? 4, and propane is 1. Then Avogadro's number will come here, 6.022 plus 23 H2O molecules to 1 mole of H2O. Are you following me here? Yeah. Ours is correct if they are, ours in the impression they like to see propane. Correct? Ours is correct if they ask for propane. But if they ask for H2O, then you have to get rid of the propane first. Get the H2O, and then you multiply by Avogadro's number. Yeah, their approach is correct. Their approach is correct. So, let's take this one out. How many H2O molecules? That's the answer here. The answer is 8.2. Yeah. So, let's do this one here. This is very tricky. It will not come, but it's, you'll be surprised about the answer. There's no calculation here. This is analytical thinking only. So solve this and see what's the answer here. What's the answer?
Isn't it 0?
Yes. How do you know?
I just remembered we did it last time in class.
Last time we did it? Okay. That's good. That's good to memorize this. But
if it's like the 3 mole, then we cancel out.
correct. So I put here, I need 3 mole of sulfur. So I have to multiply this one by 3 to get 9F2 plus 3S plus 3SF6 correct? You have actually 9F, 2, and 4S. So the S is here left over. How many? Will be 4 minus 3. Will be 1. And here how many? 9 minus 9 makes what? 0. That's not really calculation. That's just analytical thinking. Correct? The answer is 0 here. The answer is 0. Don't worry, those type of questions will not come. Those type of questions, they are not coming. Okay, guys? What's that? Next Tuesday? Next Thursday. Red's Cantron, yeah. Yeah, those who came late, we talked about this. There are, nothing will be accepted after the 9th of December. Next Monday is the last day of class and the last day of submission of any outstanding stuff. Extra credit, CHEM 101 active, quizzes, exams. If you have any outstanding items, just let me know before the 9th. Yes?
We don't have class next Tuesday. We do.
Which one?
For a lecture.
Next Tuesday? No.
No class.
After the last day of classes is Monday the 9th.
Okay.
After the Monday the 9th, no class. Don't come to the class. The class is done. The last day is the 9th. After the 9th, there are no classes.
You mean only this week?
What's that?
You mean only this week we have the class?
This week is the only thing. Today is Tuesday, and Thursday we'll have a class, and that's it. Next Thursday will be we'll come here from the lecture, we'll go to the final in the lab. Okay, guys? So, yeah, you have to bring a red scantron and a pencil or 2, or pencil mechanical or graphite number 2. Bring your ID and non-graphical calculator, simple one. Or graphical one, but does not have a USB access or inlet or outlet, USB outlet or inlet. So because that's, you can download everything in this calculator. Those are not really calculators. Those are semi computers, because you can download, you can upload, you can do a lot of things, but they are limited. The iPad is one stage higher than them, but they are semi-computer. The iPad is semi-computer, but more powerful than those calculators. Yeah, those are not a calculator. The real calculator is the simple one. Simple function, math functions, very simple. That's a real calculator. But if you have TI 85, HB something 84 and above, those are really acting as a computer, semi-computer. So you can download into them. You can download stuff inside them. Okay, guys? And you can reprogram them. You can put even small tiny programs inside. So simple calculator will not do that. Are you following me here? And all those calculators, the semi-calculators, they are, if you have taken this, I have taken this long time, I forgot everything. C++ language, computer language. C++, it's a beautiful language, computer language, yes. Well, I will try to bring some from the lab. Those are what they call it, solar ones. But the solar ones, you know, they are very sensitive for the light. If it's not enough light there, they might start shaking. So you might, question your answers. I will bring them in the lab. In the lab is more light than here, I think. The light of the lab you have seen, the brand new building, it's a very powerful light. But in this type of lightning, I will really start questioning the answer. You know, if you have a dark area, those solar calculators would not work very well. I would never trust them in a dark area. And here the lightning is not that as good or that strong. But it's up to you. I'll bring those. But you can buy one with $8, yeah, or $9, and keep it for the future. So, okay, guys, where we are at now, we are at this. Yeah, the answer is 0. Okay, here it is. What is the maximum amount of ammonia that can be produced when 0.35 mole of nitrogen reacts with 0.9 mole of hydrogen? What's the maximum amount of ammonia can be react with? Of course, those type of question will never come. Why? Because those type of question is limiting theoretical yield, and they will eat up your time. So I doubt that they will bring this. Will be very mean if they bring this, because that's a lot of calculation involved. Okay, guys? They need the product is ammonia, correct? And you have both. Nitrogen is 0.35 mole, correct? And this one, how much is it? 0.9 mole. Well, you have to do first determine which is excess, which is limiting. That's very important to know which one is excess, which one is limiting, correct? Well, you start is amount of ammonia is number 1, based on nitrogen. That will be, nitrogen is 0.3 mole, mole of this nitrogen, mole of nitrogen to mole of your product. You look this one up from the equation here. This is mole here. So mole with the mole cancels out. Mole of nitrogen, you have 2 here, and here you have 1 understood, not written. 1 to 2, correct? 1 to 2. So how much is this? 0.67. So 0.70 moles of ammonia, correct? Then you will do the same calculation here. Ammonia amount based on hydrogen, correct? So let's see how much the number of moles. So based on hydrogen is 0.9 mole hydrogen, mole of hydrogen to mole of ammonia. Ammonia is 2 here, 2 in the top. Hydrogen is 3. So how much is it? 2 multiplied by 0.9 is 1.8. Divided by 3 is point what? 0.9, correct? Is it? 0.9? 0.6 or 9? 6. Ammonia. So this is 0.6. The other one is point what? 7.0. So what's the maximum will be? The answer is C. Correct? That's the maximum. Okay, guys, so let's see. The answer is P. 0.6, and the other is point. What's the maximum amount of ammonia that can be produced? The answer is P. The minimum or the maximum? Yeah. They are correct. We base our amount coming out, but we have to base based on the limiting reactant is 0.6. 0.6 is correct. So it's you base your stuff here on the limiting reactant. Oops, sorry. So not 0.7. No, that's not correct. Theirs is correct this time. I don't agree with many answers, but this one is correct because the limiting reactant is your nitrogen. Nitrogen give you hydrogen. So 0.7 nitrogen of the product, and hydrogen is 0.6. Always that's the limiting. Hydrogen is limiting. So you base your yield on the limiting. Okay, on the limiting, not on the excess. The excess is not. So their answer is correct on the limiting. Yeah, their answer is correct. So let's do this one here. How many total molecules can be present when reaction of 5,000 molecules of CS with 15,000 molecules of O2 goes to completion? So you have this one here is, same thing we did, just we have to see which one is limiting, which one is. So this one, how many? 5,000, correct? And this one, how many? 15,000. Don't worry about the molecules. They don't ask you about the total molecules will be present. You need again of the reaction of what will be the total molecule will be present when reaction with this molecule of so the question is, what is the limiting reactant? They should really tell you what's the limiting reactant. Then from the amount coming out, then you can see what the limiting reactant is, correct? So you can take any of those. How many total of molecules will be present? Reaction of this with this goes to completion. Now they did not specify what molecules, total molecules is that. So see, those type of question they have really to specify. Now, if we wanna take CO2, okay, as a product, for example. So CO2 as a product. So, but they are asking you now, not the limiting, they ask you total. So let's, for the CS, how many we have? 5,000, correct? 5,000. They did not specify what molecules. And those type of questions is not correct. They have to specify total molecules of what. So you have a CO2, you have 5,000, correct? Based on the CO2, so the design of the question is not correct. So 5,000 of molecules, correct, of CS2, this is 1:1. One molecule, or you look at the equation here, CO2 is 1, this is 1 from the equation. One molecule of CO2 to one molecule of CS. So this is not more, molecule. So molecule cancels out, and you get 5,000 of CO2. Okay, guys? So now if you take the oxygen here for the CO2, you get the oxygen 15,000 molecules of O2 over one CO2 is one molecule. Here is one molecule of CO2 to how many molecules of oxygen? 3. to 3. So molecules, oxygen molecules cancels out. 1 over 3. So 1 over 3 is how much? 5,000. So I specified this because this type of, the question is not correct. You have to specify total molecules of what? You have 2 products. You have to specify which one you want to calculate the total. Okay, guys? And you can do it, this is 5,000 and 5,000 for both reactants, and you can do it for option if they don't ask for the second product as well. You can calculate for the second product how many molecules if you have both of those. That will be just overkilling. The same calculation you can do it for SO2. Okay, guys? But this type of that's my opinion. I did not make those questions. You have to specify which one you have, molecules of what. Otherwise, then you have to put for this, calculate for this, and then calculate for the other one. Just for this one here itself, 5,000 plus 5,000, correct? 5,000. The other one's 5,000. That's 10,000 for the CO2. You do the same calculation for SO2 and then calculate the total. So let me see what they have. They approach it. They will show you how they approach it. Here, guys, look at that. They did it the same thing I told you. For CO2, 5,000, correct? Can you see the answer here? Can you answer? So, see, they assume because you are using small amount of this is the limiting, and they did the same thing we did, correct? So, and they calculate for both. They calculate for both. Can you see, guys, those? So, here. That's their answer. Answer is C, but the setup is not correct. You have to specify which one you are relating to, and you have to calculate which is limiting, which is in excess. So anyway. Anyway, so let's take another one. Oops, sorry. Let's take this one here. Again, this is a limiting reactant. You will do the same thing we did. So you have 2 reactants. You have to determine which is limiting. So you take one of the products. So this is reactant, this is reactant. Now you can take your calculation. They base their calculation, what is the theoretical yield of lead. So this is the reaction, this is the product desired. This is the correct approach. Are you following me here? This is you have to specify what product you are dealing with, correct? That's the product, and then you test those two items here, those 2 molecules. Which one is limiting? Which one is in excess? Correct? You want me to do it, or you can do it yourself? Okay. So let's do some calculation per mole. So you have what is the theoretical yield obtained by the reaction of this lead oxide, lead 2 oxide. You start whatever is given to you. Lead oxide. I need to get the grams out of my way. I have to use the molar mass, correct, of the lead oxide. So how many lead oxide? Is the top is 2 and the bottom is 223.2, 1 mole. Okay, guys? And then I have to look at the ratio between this mole of lead oxide to my product. Desired product is 3 this mole of lead. 3 to 2. Then you have this. Okay? That's for to determine the limiting reactant. And you can further this one here, by the way. You can do this one here. Multiply by the molar mass of lead, which is 207.2 grams of lead to mole of lead. This is lead here. Mole of lead to mole of lead oxide, grams with grams. So this we get number of grams of lead based on lead oxide. You can do the same thing here, and you can compare those two here by the second one. So let's do the second one. Second one, you took 33 grams. Okay, guys, here it is. Just this here. Okay, took I know what's happened, but you took what, the 33.8. Start acting up here. 33.80 gram of lead sulfide. You multiply it by the molar mass of lead sulfide, 239 gram of lead sulfide per mole of lead sulfide. You go to the mole ratio. Here you have 3 mole of lead. Okay, to how many of the lead sulfide? To 1 mole of lead sulfide. Mole cancels out, grams cancels out. You have 3 moles of lead. You multiply it by 207.7 whatever 0.2 grams per mole of lead. So the mole cancels out. So from this whatever you see, you just divide this here, take this divide by this value, multiply it by 3, and divide this value here by this, multiply by 3 over 2, and then multiply it by the molar mass or atomic mass of lead. So how much is it? Where is the answer? Where is the answer, and which is limiting? Your answer will be based on the limiting. Which one is limiting here? I can visualize. This is the same value, correct? This is the same value. However, this one here is 223, 239. This is larger. I think this one will be limiting. This one is smaller, right? Is it? Which one is limiting? Did you get the limiting, guys? Because what's that?
C.
The answer is C. Okay, so based on the limiting, correct? Which one is limiting? Is it this one is limiting?
Yes.
Or this one? This one is limiting, correct?
Yes.
So then that's the answer based on this. So it's C. Let's see if we have correct. The answer is the answer is C, correct. Perfect. The answer is C. So I think I will pass No, that's different. We are out of the limiting. Now this different topic. We have potassium iodide and sodium acetate and lead nitrate are mixed together. What precipitate forms? That's a table of solubility, correct? So you have potassium iodide, and you have sodium acetate, and you have lead nitrate. You mix those together, correct? Mix together. So we know that the nitrate is 2 here. All the nitrate are soluble. So anything with nitrate will be soluble. So no precipitate, no settling down. Acetate, anything with acetate will be soluble. Potassium, anything with potassium is soluble. Anything with sodium is soluble. The only thing left with not soluble is the iodide and the lead. So the answer is iodide plus lead. This is 2 here, or this is 2 here, lead, iodide. Take the 2 out here. So this one here will be forming. Correct, guys? This one will be forming. Is this an option of this? Yes, where is it? D. The answer is D. The answer is D. So, let's take this one out. The answer is D. That's correct. So, which combination will result in precipitate? I'll give you less than 1 minute. Which one will precipitate? The same thing we did. The same we did just 1 minute ago. So, how I solve this? Well, anything with sodium is soluble. Anything with sodium is soluble. Anything with hydroxide, not soluble. Correct? The same thing with the iodide. This one here, soluble. That's the way you can see. Anything with the chloride is soluble, except when it's connected to the iron. So hydrogen is soluble. So I have the problem with hydroxide. Now hydroxide will have nitrate is soluble. Nitrate, all the nitrate is soluble. And if you mix the, double displacement, iron, nitrate, that's soluble because nitrate is soluble. Correct? Now, zinc and HCl, that's no solubility. There will be zinc chloride, which we said hydrogen is soluble, and hydrogen. But here you have iron and you have hydroxide. Hydroxide is not soluble. So you mix this one here plus iron. This is 3 here, will be FeOH3. Iron 3 hydroxide insoluble, correct? So the option B, that's when you make the hydroxide insoluble with iron. All the other ones, all the other options are soluble, correct? So let's see. The answer is B. The answer is B. As you see here, the answer is this one here, B. Hydroxide is not soluble. So, balancing, what is that? What is the balanced net ionic equation for the reaction CuCl2 plus and hydrogen gas? Okay. Okay, so copper, Cl2 aqueous plus hydrogen gas, correct? Plus hydrogen gas. So that's the reactant. What will happen there? So can you tell me what will happen? What's the net ionic? So this is aqueous, you have to take it apart. This has, you have to take it apart. Aqueous plus 2 chloride, aqueous, correct? This one you have to take it apart. Can I take the hydrogen apart? No. Hydrogen will be remaining as a gas. Okay, guys? So now I know that I am keeping all those without nothing there, without any. So which one will be correct then? Which one? D. Yes. D is correct because you can't take apart the gas or liquids or solids. You can't take them apart. Keep them aside. And then this one is only aqueous. You can't take them apart. So kept this, kept this, kept this. Okay. Then whatever is there, correct? So let's see. D is the full ionic equation. The answer is D. The answer is what? The answer is A. This said answer is A. But where is the chloride? Chloride can. Oh, D is not, because the chloride from both sides are canceling. We missed this one. He said D, but I said with you D, but D is not correct. Why is not correct? Why is not correct? Because, yes, those are spectator ion. There is this, there is this. They have to cancel out. Correct? They have to cancel out. So that will be A, then the correct one. Without the D and A are equal, except D is as spectator ion chloride, which has to be canceling out. So we rushed to the answer. Correct? So what is the oxidation number of chromium in sodium dichromate? Okay, well, I have, this one I will help you with. So I have sodium 2Cr2O7. The sum of all the oxidation number is neutral. This is 0, correct? This is 0. There's no oxidation number there. So 0 equal to 2 sodium plus 2 chromium, correct, plus 7 oxygens. So sodium always plus 1. That's sodium. 2 chromium, I don't know because it has multiple charges, plus 3, plus 6, plus 5, we don't know. Plus 7 oxygen are always like sodium. Sodium is plus 1, group number 1. Oxygen is always minus 2, or most of the time, 99%. Sodium in ionic compounds plus 1 all the time. So you have 2 plus 2 chromium plus minus 7 minus 2 is minus 14. Correct? Minus 14 plus 2 makes what? You have this one here, 0, equal to what? Minus 12, correct? Plus 2 chromium. So the other side, 12, equal to chromium. Chromium then divide by 2, chromium is plus 6. Can you see it? So the answer is B. The answer is B. So let's see here.
12, is it divided by?
12 divided by 2.
Okay.
Because it has 2 chromium, correct? See here, the 2 here? 2 chromium.
So how do we get rid of the negative?
7 multiplied by 2, minus 14. Minus 14 plus 2, minus 12, correct?
Yes.
Minus 12, add to both sides 12, add both sides 12. So it will be 12 the other side, 12. Here they cancel themselves, here will come 12. Then divide by 2 plus 6. So the answer is 6. So let's take this one out. And let's see. The answer is plus 6, correct? Plus 6, that's correct. Which is an example of an oxidation reduction reaction? Which is an example of oxidation reduction reaction? What do you think? Which one is oxidation reduction reaction? Which one you think that's really, looking at the reaction, the only one is not really oxidation reduction is the double displacement. So this one is not. That's double displacement. You don't change anything of the oxidation number, correct? Lead will go with the sulfate, and the sodium with the nitrate. So that's double displacement. That's not the case. How about looking at this here? This double displacement. Again, double displacement here. Rubidium will take over the chloride, hydrogen will take over the OH. Okay, so now we have to consider only this and this. So, which one? Oxidation reduction. This is decomposition reaction, correct? CO2, ammonia. C? No, C displacement. A and C is displacement. How about this one here? The lead is what? The lead is 0, correct? And here the lead is, this is oxygen minus 2. 2 minus 2 is minus 4. Oxygen is plus 4. Plus 4. Give you the lead here, sulfate is minus 2. The lead is plus 2. So this is oxidation reduction equation. Oxidation reduction equation. So, okay. So the other one, which is this one here, H2O came out as is. Nitrogen came out as is. So the answer is D, because you have plenty of oxidation change. Okay. So let's see here, and then I'll stop here. The answer is D. The answer is D. Correct. So guys, I'll stop. I'll meet you this coming Thursday. If you are in my lab, we'll have the lab final. The lab final will have titration, practical. It will have a practical question. So be prepared. Review how to calculate the molarity of acetic acid, mass over the volume of acetic acid. You have to know how to do that. Okay? And I think you will be using your what they call it, your burettes and all the stuff we did before. Thank you very much. Bye-bye.